and a very good day to everyone. My name is Xiaohui and I'm now pursuing my degree in University Tenaga Nasional Unipen. I am currently doing my second year first semester mechanical engineering degree course under College of Engineering COE. Well, this video is one of the assessments for my Moral and Civil Society 2 with subject code MPU 3422. Without further ado, let's get started.
In this video, I will talk about a foundry process on sand casting. I'll explain it in a very simple way so everyone can understand. Let me introduce myself once again. My name is Jia Hui with student ID ME01081448. The first objective of the video is for me to share some of the manufacturing processes knowledge that I've learned in classes to everyone who is watching this video. Next, this video aims to let viewers explore the processes when manufacture a product. Besides, through this video, we can differentiate between the two types of sand casting processes, which are removable pattern and disposable pattern. Let's get into our main topic. First of all, before we look into sand casting, let us have a quick look at what exactly is a foundry process. First, making mold. In this stage, cope and drag, patterns, empty cavity, and silica sand are constructed. Next, melting the metal. The solid metal is exposed to high temperature in a furnace to become molten metal. It has to be in molten state only, then it can follow the shape of cavity. Then, we pour the molten metal into the mold we constructed to allow solidification process to start and to obtain the casting, which is our product. Lastly, clean the casting. The casting, once it solidifies, doesn't appear to have a good finishing surface. So to make it a smoother surface, we need to do some finishing processes such as sandblasting and grinding. Then only the product can be sent to do coating with paint, electroplating, and so on. Making the surface smooth is to ensure the coat will not tear off easily. Isn't the whole process sounds familiar? We can just imagine the process like a jelly making process, which we prepare jelly mold, melt the agar strip to liquid state, pour it into the mold, and let it solidify. Okay, so now let's move on to the sand casting. Sand casting is divided into two types. The first one is removable pattern. What's so special about it is that this method can produce symmetrical product. It uses wood pattern which can be used repeatedly in the process. The illustration for this process can be seen from the picture on its right. The second sand casting method is disposable pattern. Through this method, aesthetic design can be produced by using polystyrene pattern. However, there's no repeatability for the pattern, and I'll tell why later. So this is how disposable pattern looks like. So we know that removable pattern uses wood pattern, has repeatability, and produces symmetrical product. In this picture, there are few important components that build up this method. They are cope and drag, molten metal, pouring cup, sprue, gate, riser, cavity, and vent holes. The operation of removable pattern sand casting process starts with constructing cope and drag. Sand is well compacted around the wood pattern, and the pattern is removed to create an empty cavity before casting process. We first melt the solid metal at high temperature. Then we manually transfer the molten metal using a ladle into the pouring cup. The molten metal will flow through the sprue and gate, and finally it reaches the cavity, the casting. When the metal solidifies, we open the mold, break the sand, and take out the casting. And finally, the casting is sent to do some surface finishing. So now, we look at the functions of those components I mentioned just now. Cope, upper half of the mold, drag is the lower half, pouring cup, entrance of molten metal where we pour our metal into the cavity. Sprue, create passageway for molten metal flow. Gate, a way which leads molten metal to fill up the cavity. Riser, to compensate for shrinkage of casting. Some metal will shrink when it solidifies. And the molten metal in riser is the last to solidify or never solidify to supply molten metal to the cavity because riser itself is made out of metal. Casting or cavity, the empty space to be filled up by molten metal to form casting. Vents or vent holes to allow trapped gases to escape and prevent it from traveling back to the casting. to avoid any bubbles formed on the casting surface. Next, we look into disposable pattern. The process is much simpler than removable pattern. As we know, disposable pattern uses polystyrene pattern which has no repeatability and can produce a static product. The polystyrene pattern is soft and it is easy to turn into any size and shape. The polystyrene pattern is surrounded with the compacted sand. The pattern just stays there and we don't need to remove. Because the high temperature molten metal will pour on the polystyrene pattern. Polystyrene has very low melting point, and when it needs high temperature molten metal, it vaporizes and molten metal takes place and fills up the cavity. The process for disposable pattern is just as simple as that. So I have explained the process of removable pattern and disposable pattern. Now let's look further into the advantages and disadvantages. In removable pattern, as we know, wood pattern is used and it has repeatability. It produces symmetrical size, and because the wood pattern is used again and again, the size and shape of the product is exactly the same. However, look at the disadvantage. Removable pattern is tedious and time-consuming as we need to manually construct the comb and drag to make sure it is symmetrical and so on. We need to give a bit tolerances too when we construct cavity so the compacted sand is not disturbed when we remove the wood pattern. For disposable pattern, apparently the production time is much lesser compared to removable pattern, and the molding process is simple and we don't need to give tolerances to remove the pattern as the polystyrene will evaporate after meeting high temperature molten metal. Although the polystyrene pattern makes this method much easier, but it brings the disadvantages too. It has no repeatability and it breaks easily, so if it breaks in between and we can't check the final cavity before casting process. So if anything happened in the casting, we can't notice only until the casting is taken out and we figure out, oh, something was wrong. Next is environmental concern. Why does it say so? Because when polystyrene vaporizes, it releases poisonous gas, which is toxic to the environment. Before we proceed to the next slide, I hope you discover something, which is sand casting. The word sand. Silica sand is used to surround the pattern and create an empty cavity. Why? Okay, but why silica sand? Why? So it is readily available, low cost, and inert. Well, these are not really the important criteria which make silica sand the best choice in casting process. Its first criteria which makes it suitable is due to its multiple grain size. Because of the multiple grain size, some are big, some are small. When they are compacted together, there is only very minimal voids between the grains, and hence crack is hardly propagated across the sand. Next is the refractoriness. The silica sand does not fuse with the high temperature liquid metal during the casting process. Now, let's look into common used sand type. The first one is furfuryl alcohol binder mold, which had components SiO2, the silica sand, phosphoric acid, sulfuric acid, and furan resin. This type of sand is widely used in disposable pattern. Next is CO2, carbon dioxide mold, with components SiO2, sodium silicate, and the supply of carbon dioxide gas to harden the sand. This sand is used in removable pattern. So this is a summary of what I have shared so far. So in foundry processes, one of the foundry processes is sand casting. While in sand casting, we have removable pattern and disposable pattern. In removable pattern, the advantage of it is it has repeatability, but it is time consuming. In disposable pattern, it has less production time, but it has no repeatability. Last but not least, the silica sand. Why we use silica sand? It's because it has multiple grain size and it's because of its refractoriness. Okay, so that's the end of my sharing.
I truly hope this video will be beneficial to you. That's all I want to share. Thank you.